All right, greetings, fellow grade 10s. It's Mr. Hlajoyo again. Look, welcome to Back to Basics. Now, what we are going to be checking on today, basically, we are still checking our 2D shapes in trigonometry, right? And what we are looking at today, basically, we are looking at a past paper of November 2017. Now let's look at it. Now, firstly, they say RQ is a vertical pole. They say the foot of the pole Q is on the same horizontal plane as P and S. The pole is anchored with wire cables RS and RP. The angle of depression from the top of the pole to P is 47 degrees, and your PR is 21 meters, while your QS is 17 meters. Now you are given that your RPQ, it is your angle theta, right? Now let's look at the first question. Now the first question require us to do it. Now it requires us to find out, or rather to write down, what is going to be the size of theta. What is going to be the size of theta? Now, in order for us to write this size of theta, surely you can see that now if you can, draw and extend this line here, draw and let's say extend this line here, surely these lines are going to be parallel to each other. And now what you know about now angles that are within parallel lines, look, now if you can extend this line, surely you can see that these angles you see from here are, going down here, up and here, up until here, you can see that they are forming a Z, which means they are alternating, which means your first your first answer for your 6.1, it is going to be what? That angle in there, it is going to be your 47 degrees. That angle in there, it's going to be your 47 degrees, or rather your theta, it is going to be 47 degrees, right? Oh, it's okay. Now let's look at now our 6.2. Now for our 6.2, what they want us to calculate now, they want us to calculate what is going to be now the length. What is going to be the length of our RQ? What is going to be the length of our RQ? So basically, they want us to calculate this, which means they want us to calculate this particular line. Can you see that? Now, what is it that we are going to do? Already now we found out that this is going to be 47 degrees, right? So if you can look at now in our triangle, what in our triangle RPQ, if you can look at triangle R in triangle RPQ, what is it that you can find in? Now in angle R, rather triangle RPQ, now this triangle, what is it that you have already? Now you have this angle and you also have your hypotenuse side, right? So you have this angle in here and you are having your side that is hypotenuse, and your RQ, basically your side RQ, it is the side that is opposite to the 47 degrees that we just found, right? So which means now you are having the side that is opposite and you are having the hypotenuse side. So which means amongst the three trigonometric ratios, which is your sine of theta, which is given as opposite over hypotenuse, your cos of theta, which is always your adjacent over hypotenuse, and your tan of theta, which is going to be what? It's TOA, which means it's opposite over adjacent. You can see that the only trigonometric ratio that can give you that, it is going to be your sine of theta, because it gives you your opposite over your hypotenuse, right? So which means here, what is it that you are going to have? You are going to have your sine of your theta, which is going to what? You're going to have your sine of your 47, because you already found out what is your theta, isn't it so? So this is going to be now your sine of your 47 degrees, which is going to be now the opposite side. It is the one that you're looking for, which is your RQ. Divide by now the hypotenuse side, which is your 21, right? So which means now after here, you are then going to cross multiply. You can make this to be over 1, and then now you multiply this. So which means now your RQ, it is going to be given by 21 sine of 47 degrees, right? And when you are doing that now, therefore, which means your RQ that you are going to find, it is going to be given by what? It is going to be given by 15, 6.36 meters. So that is going to be your value of your RQ, right? Now let's then continue and look at our 6.3. Now, in our 6.3, what is it that now we are looking for? 6.3 want us to calculate what is going to be the size of S. Now, remember I said it is always important that whenever you find something from there, you do what? You come back to the formula and you are doing what? And you come and you are substitute it back. Now, what is it that now we are going to have here? Let's try and get another nice color. Now, here already now we found that this side here, your RQ, it is 15.36, right? And now let's see in terms of what else now can we have in order for us to calculate your size, your size of S. Now, for us to be in a position now to calculate our size of S, what is it that now we can use? Look, you are given this side here, right? You are given this side here and you are given this side. Now let's look at the relation of both of these sides that you are given in relation to your angle S. Now, if this is your angle S, now the side that you are given, first we are having this side which is opposite to your side S, and you're having this side which is adjacent to your side S. Now, or rather your angle S. So which means which trigonometric ratio then are you going to use? You are going to use your tan of theta, right? So which means now you are going to come back and say, look, now your tan of your angle S, in this case, it's going to be the opposite one, and the opposite side is given by what? Isn't it that it's given by your RQ over the adjacent side, which is your QS, right? And when you come back and substitute all those things, now this is going to be the one, the 15.36 divided by, now what is going to be the one in our denominator, it's going to be the 17. So therefore, which means your angle S now, it is going to be shift tan of, your 15.36 all over your 17. So which means your angle S that you are going to be given in here, it is going to be 42.10 degrees. That is going to be the angle S that you are going to be given in here. Are we together? Then now that's going to be that. So, and again, remember, I said it is important that whenever you are finished doing anything that you are calculating, you come and you substitute. This is the one that you found here. It is 42.10 degrees, right? 10 degrees, or rather 10 degrees. Now let's look at the last one. Now they say if P, Q, and S lies on a straight line. They say if P, Q, and S lies on a straight line, how far apart are the anchor of the wire cables? Now, so basically they say if these things lie on this one now, right? If this they are anchored in here, they want you to find out in terms of how far apart is the distance going to be from probably here up until here, and the one from here up until there, right? So they want you to calculate that. So now, but now look, we already have what is the distance between our Q and S. So the first thing that we can do now is we can find what is going to be the distance between our P and Q. And now how are we then going to do that? Now, in order for us to find the distance between our P and Q, there are many ways that we can do. But now if we come back here, look, now the one thing that you had in this triangle, now let's write this in here, your 6.4. Look, now in triangle, let me mention this triangle. In triangle, this is triangle, RPQ. RPQ, what is it that we already know? Now you are given the angle here, and you are given the side that is going to be a hypotenuse side. And in relation to your theta or your 47 degrees, the side that you're looking for, it is adjacent, right? So therefore, which means in this case, we are going to use the cos ratio. So now this is going to be the cos of what now? This is going to be the cos of 47 degrees, which is going to be given by what? Now which is going to be given by what? Remember, cos it's adjacent, and the adjacent side is the one that is your PQ that you are looking for, and the hypotenuse side it is the 21 in here. This is going to be the 21 that you are given over there. So which means now what is going to be now our PQ? So when we divide here by 1 and cross multiply, your PQ that you're going to find, it's going to be 21 cos of 47 degrees. Isn't it so? And now what is going to be there for the PQ that you are finding? Now the PQ that you are going to find here, it is going to be 14.32 what? This is meters, right? Now you are given this in terms of meters, right? And now what this question basically is asking, they say now, how far apart are the anchors of the wire cables? So this is one of the most important topic, right? So what is it that now we are going to do to know how far apart, which means now basically now if I can use another nice color there and highlight here. So basically they want you to calculate what is going to be now the distance from here combined up until here. So which means from P and S. So now, which means now for you to find what is going to be your PS in terms of the distance. Now your PS, remember, it is going to be given by this distance from here up until here. And again, the distance from here up until here, right? So then when you add both of these distances, look, you are having 4.32 firstly, plus what is going to be the other one? The other one is going to be 17, right? So which means the totality of your PS in terms of distance is going to be 31.32 meters. So this is how far apart these cables are going to be from each other, right? Now, hopefully this will make sense to you. Thank you very much.